And now we're going to be creating our scene and controlling a procedural terrain. And we're going to be controlling a blender, basically linking a blend of a combiner and controlling that with a fractal, and then modifying the origin of the fractal with the node we've created. So I'm just going to set up a procedural terrain and position it. We're going to go a little bit above the ground plane since we have some negative areas that right now are intersecting. I'm going to edit our object, and we're going to stick with our default object parametric mode. Turn off zero edges so we can see the most of our procedural as possible and without any interference from that smoothing of the edges. So we're going to keep that off. Go into our function. I'm going to delete the offset that's been pre-created as the seed. We're going to create our combiner node by selecting the link between altitude and the output of our fractal. And our combiner is going to be blend. And now we're going to create another fractal node. And we're going to create some different variations rather than just this simple Perlin noise value. And what I want to use is a cellular pattern Voronoi. And then our other fractal we're going to change to Perlin noise terrain Perlin noise. And I'm going to open up the output observer so we can see our current terrain we have showing up. We're going to connect the other input to the altitude, just as the first fractal is. And now we can take a look at how these are going to blend into each other. And I'm basically going to stick with the defaults. For the most part, not really going to make any major changes. I am going to edit the terrain Perlin noise and set our billow ridge amount to 0 to give us more of a billowy look, and then increase our distortion slightly. We'll go ahead and just type in a value of 0.25. So now these are our two primary fractals, and we need to control this with another fractal. So I'm going to add in one more fractal. We're going to change this to Perlin noise gradient, and we're going to connect our blender and the altitude of our simple fractal. So now these two are going to be blending together, controlled by our simple fractal. And then we do want to see exactly what the blender looks like by itself. So I'm going to disconnect the altitude from our blender and just connect it directly to our ratio controller. Just so we can modify this node a little, I'm going to turn down the roughness, increase our gain, and also switch our preview options up the upper left to 2D plane, and we can see a little bit better within the node editor. And we'll go ahead and change our metascale up to 40. And now this is going to be our blend between the two. We can go ahead and connect that altitude back. If needed, you can select the link, delete it, and reconnect that. And now we can see a nice blend between these two procedurals. I'm just going to click OK right now. And we want to adjust our altitude within the scene. Because we have some pretty high gain, we're going to end up with a very high terrain. So what we need to do is select our scale. We're going to scale this down on the Z. I'm going to select our main camera and turn off the height lock. Because sometimes when the camera is above our procedural terrain and we're trying to make modifications to the scale, you can run into some kind of glitchy problems if it's manipulating the height of our camera. So let's just position the camera just above our terrain. Go ahead and zoom in a bit. And just give ourselves a pretty good range. And now I also want to connect some materials to this blend. So we're going to go back into our procedural terrain, and I'm just going to go ahead and save this right now. And then we'll right mouse click, edit the object. And when you're working with the procedural terrain, you can turn down the pixel resolution. And that way, every single time we open the terrain editor, we're going to end up with a much quicker refresh to get to the procedural tab. And now when I hit edit object, it refreshed very quickly. So the lower that amount is, since we're working with a procedural, that pixel amount really doesn't matter since we haven't manipulated or painted on the procedural. Then that's going to be fine. So now what I want to do is take and add in an output node custom dependency. And we're going to call this terrain ratio. And we can connect this to our simple fractal that we have controlling the ratio of our two other simple fractals, where we have the Voronoi pattern and then also the terrain Perlin noise. I'm going to click OK and close these windows out. And now we're going to double click on the material preview up at the top, and I'm going to rename this to terrain because we don't want it to have the exact same name as our ground plane. I'm also going to click on the icon for the ground infinite plane just to hide that from our render. We can go back into the terrain material. We can see that it's named terrain. And what we're going to do is create a mixed material. And let's load in two different materials that we want to set up. One to control the Voronoi pattern and one to control the terrain Perlin noise that we have set up. So let's load in under material layers the grass layer. And it's going to ask if I'd like to ignore the alpha information. And these are really meant for the layering materials and stacking. So they have built-in alpha channels. So we're going to go ahead and edit the material by right mouse clicking and then edit the function and just delete the grainy fractal that we have for the alpha, and I'm going to delete the bump channel as well. That way we're going to get a little more quicker response time, and since the procedural terrain itself has all the detail we really need, we don't need to have a bump channel on the material. And we're going to load in for material 2 our large scale rock. And we're going to ignore that alpha information, edit the material, edit the function, get rid of that bump, and there shouldn't be anything else connected to it. Go ahead and click OK and close those out. So now we have our two materials, and what we'd like to do is blend them the exact same way our noises themselves are being blended. So we'll edit the function for our distribution, add in an input node external dependency. And then we can select procedural terrain, the terrain ratio custom dependency we created. Now we can connect that directly to the external node, click OK, and it's automatically going to distribute those two materials on top of each other. Now, really depending on the amount of gain used and the blend, because we are using a fractal to convert to a number, it might not be perfect. So we might need to make a few modifications, maybe using a filter, or even just adjusting the mixing proportion. So right now what I'm going to do is set the mixing proportion to 45. And we can click in the main camera preview to see what that's going to look like. Go ahead and make that a little bit larger. Make sure our preview quality is set to fast. So right now it looks like we need to switch the two materials that we have, and we can either swap this, but I think what I really want to do is just create an opposite output. So we're going to connect the link in our distribution between the distribution output and the external dependency input, add in a filter node, and set it to opposite -x. That's going to invert our distribution. And I'm going to set the mixing proportion to 50. Looks like we might need to go a little higher, set it to 55. And we should start to see those Voronoi patterns getting our rock material on them. We can increase this value a little higher if we need to. And that looks like it should be a pretty good match for our blend, because the blend is really going to vary, and we also have some other controls. Smooth blending strip, which will create a much greater blend between the two materials. We could turn that off completely, and that's going to create sort of a threshold on top of our distribution. So this number might not be exact, or the output that we have, because we do have a smooth blend already part of the material itself, and the smooth blending strip is going to take that over. So we'll enter in a value of 5 and smooth that out just a little bit more, but we want some pretty good definition between the two materials. Maybe we'll go and set that back to 10. Keeping in mind too that our mixing proportion will also sort of clip out and create a threshold within our distribution output that we have. So this looks like it should be pretty good. We could choose one of the other modes if we wanted to create different bumps. But there's no bump channel, so we don't really need to worry about that too much. You could always switch to the cover mode, and now we can see a very harsh strip. If we change our blend to more progressive, so there's different ways we can control it. In this case, we would set our material 1 and 2 influence down, but let's go ahead and change it back to where it was. Simple blend, 10 for the smooth blending, and we had 60 before. Let's go ahead and use 58 and see how that's going to look. Because we do want to have some of the grass in there still, and that should be pretty good. Actually, we'll go ahead and set 262, just so we can get rid of some of the areas over there, and it might have been a little bit too much. So I'm going to stop tweaking and just set this back to 60, where it did look pretty good. Of course, this is going to end up animated, so that value might need to be changed. Okay, so now we have the material set up for our blend, and what we want to do is load in our node for the procedural distribution and also create our control object. Our control object is going to be a sphere. We can see that showing up. We're going to change this to the move gizmo, and if we take a look at our sphere position, we have it at 76 meters right now. I'm going to go ahead and round this off to 80 meters. And this is going to be our offset. And I'm going to rename the sphere to, let's call it control ratio. And we might as well create a new layer for our controllers, just so we can separate it from the rest of the scene. I also want to click on this icon for the sphere and hide it from our render. And we are going to go to the first tab, make sure that is not going to affect any sort of ecosystem population, and we can basically just check all of these on, and that way it's not going to be part of the G buffer, because really this is just our control. If you do want it to be part of the G buffer, you can turn that option back on, but otherwise we're going to occlude it, and I want to change our wireframe color to orange so that it stands out. And I also want to make sure I'm saving the scene at this point. And we're just going to add a number to the end of this so that you'll be able to load it in the different stages. So now this is set up, we can move over to our procedural terrain, edit the object, go into our function, and we're going to modify, extract the origin of our ratio controller, load in the meta node we created, the offset variation, and the meta nodes I've provided, you can just load in the range controller by itself, and it's going to have the complete node finalized. If you want to go back to earlier versions, there's a stages folder with all of the different steps we took in order to build it. So if you want to go through and kind of dissect the different stages, they're numerically named, you can go through the different steps. So we have the range controller, and I'll just go ahead and get rid of that offset just so the one you load in is going to match what I have here. And we're going to connect our vector off of our constant vector from the offset to our range control. And we can delete that constant vector that was created. Our controller is going to be the control ratio position, which is our sphere. And if you remember, we also offsetted the original position of the sphere, so let's go ahead and change that to, actually we're going to change it to 80, because we are going to be moving it in the negative axis. Go ahead and click OK. And it looks like it did make a little bit of a change. So maybe if we set this to negative 80, we'll be able to get it back to where it was. Okay, so basically for a vector offset, when we're going to set up our initial position, you pretty much always want to use a negative number. When you're using the number functions, then you can go positive or negative, and if you're going to be using it for both, then you might run into some conflict. But right now, we've got the negative number, which is working. And what we can do is adjust our control ratio. And we don't want the overall origin to be so sensitive. So we're going to go back into our procedural terrain, and we're just going to add a little bit of control to the position by using the vector range. And we're just going to start out with a value of 5, and then if we need to change it, we can. Because we do have a very large terrain, and we are using the object parametric mode. So we might end up with way more of a change than we really want. I'm going to hit F11 on the keyboard to bring up our timeline, and I'm going to scrub 3 seconds into the animation. And what we can do is select our control ratio object, and we're going to move this on the negative Z. And that created a pretty large change. What we can do is kind of scrub through and watch what's going on. And we can see in some points we have the terrain raising up a little too high, and it looks like this is far too sensitive. So I am going to go back into our procedural, edit the object, select our range controller, and increase the vector range to 20, which is going to create a less sensitive output. And let's take a look as we scrub through. And now the change isn't so great, but it still might be a little too high. We could also take our ratio object, maybe move that down a little bit. But we can always increase that range, vector range number a little higher to reduce the sensitivity. So we're just go ahead and change that number one more time. Because this is only a 3-second animation, we don't want a very drastic change. Change our vector range to 40. And now we have something a little bit slower and something that would match 3 seconds a little bit more, unless you wanted an increased amount. Maybe we'll just bring down our sphere just a little and create more of a change. Okay, so we're going to right mouse click now on the preview options icon, which is our little film here, and we can set up our different preset render qualities. I've got our preview size set at 4 times so that you'll be able to see it, and I'm going to stick with the preview mode for now, and 10 frames per second should be enough. It should generate 30 frames for us to take a look and see how the animation is going to look. I'm going to go ahead and click OK and let that start to render out, and we can take a look and see if our settings need to be changed or manipulated any further. And now we can see our preview playing. Go ahead and reduce the size of our main camera preview, and we can scrub through and take a look at the animation. And we just have that nice change in our terrain where the material is matched to the noises we have set. Overall, we might need to reduce the size of these fractals in order to see a little bit more change in the scene. I also want to try a variation where I'm going to move our control ratio even more and give us that really drastic change, just so we can take a look at it and render out that preview. And now we can see our preview playing on the bottom. And we can go ahead and scrub through and really see those drastic changes to the terrain and also our material that's matching up. So this is a really simple animation control. It's not super interesting, but you can see how you can just move the origin of our distributing ratio fractal in order to distribute our terrain and material, and of course have the animation control linked with the node we made. So let's improve this a little bit more, and what I want to do is take our Voronoi noise, and instead of having it stay exactly the same size, let's go ahead and increase the largest feature throughout the timeline. And because we have the origin tied on all axes to this controller, we're going to use another object to control that. So we'll add one more sphere into our scene, and we're going to set its position to 80 meters as our start. And we'll just call this control ratio 2. And actually, we'll get rid of the ratio just because we're not controlling a ratio like we are with a blender. We'll just call this control feature, since we're going to control the largest feature with it. Make sure we're hiding it from the render. I also want to make sure that these do not have the exact same material as our terrain, and right now they do. So we're going to select both control ratios, and we can right mouse click and reset the material. And I'm going to call this null. Click OK, go to our control feature, reset the material, edit it, and name it null. Which hopefully doesn't create a duplicate. And we'll take a look at the material summary, and we can see that we just have the one named null. So they both have the same material. I'm going to change this one to blue for our wireframe preview. And because we're going to have these intersecting right now, I'm also going to change our position on the X to 20 meters. And that way it'll be offset. I also want to make sure I go back to frame 0 before I make any changes. And what we're going to be using is the Y position, just because we don't have any modifications made to it. Even though our offset that we programmed into it will correct that, it's better just to avoid any problems that might be generated because of the node. Although it looks like so far everything we developed seems to be working correctly. So we're going to select our Voronoi, and we need to figure out basically the range we want for the largest feature. We're going to add in another range control. And if we want, we could also set the values we had before for our offset, just in case we decide to move it to a different axis. What I want to do is set this up before I disconnect anything. Go to our fractal, and for the largest feature, considering the scale that we're working with, a change between 10 and 20 is going to be pretty large. So let's go ahead and set up to 10 to 15. So we'll set our low range to 10 in our node we created, and 15 for the high range. And now we need to set the range for our controller, and basically what position vector do we want to control the 10 to 15 ratio, and 10 to 15 difference, so going those 5 units. And let's just set it to 20 meters, which is actually just 20, since we already have everything set up for meters. And what we can do now is select our control feature, set position. We could also change that to size if we wanted. So what we'd have to do is then initially change the size. So right now we're just going to work with position just because it's a little bit easier. Take our largest feature, disconnect it, and now we can connect it to the Y output from our range controller. And it looks like everything should be set up correctly. And I want to save a new variation, number 2, at this point, and then also add one more for our future saves. And now we can select our control feature, and on the Y, we're going to go ahead and first go to our last keyframe, which we can do by selecting either the end of the slider button or the next keyframe button, since we only have 2 keyframes in the scene, one of the original at 0, and then our 3-second one. Either one is going to work. So let's set our Y and change this to 20. And maybe we'll type in the meter just to be sure that's working correctly. And we just want to make sure that this is animated, and it doesn't look like it is. So what we need to do is take our control feature, go back to the beginning, set Y to 0, and it doesn't look like this is creating the keyframe automatically. So let's go to the end of the timeline, and what I want to do is add in a position keyframe just by right mouse clicking, add position keyframe, and now we can change the Y to 20, and it should end up animated. And it looks like for some reason our keyframe is not being created. So let's go ahead and take a look. Going in our last frame at 3 seconds with the control feature selected, and now moving it on the Y around 20 meters. And even though we have auto keyframing on, we've added our different keyframes. I'm also going to go back to the beginning and add in a position keyframe, set our position to 0, and just double check that. So it looks like we ran into a little bit of problems. just a small issue here. So what I want to do is first double check the material, which somehow can be conflicting with this, and it does tend to happen. So I'm going to give this a new material name, call it null2. And now move to the end of the timeline, and it still looks like we are unable to create a keyframe for this. So I'm going to show it in our render and see if maybe that's the problem. Okay, so this could be any number of conflict or me just missing something. But since we just did this, the exact same thing to the other sphere, it looks like we've run into a little bit of a bug. And what I'm going to try is, since we use the z-axis for the other sphere, just to do the same thing. So we're going to go into the procedural terrain, edit the object, and for our control, I'm going to get rid of our y range and set our z range, and then disconnect and reconnect the largest feature to this time to the z instead of the connection we had before. Okay, it looks like everything seems to be working good so far. We'll grab our control feature, and we're going to take a look. We need to go back to the first frame and get rid of our Y movement. Remember, we have that Z change of 80. And what I want to do is take our Z and set this to 60 meters at the end of the timeline and just see if that is animating. And it doesn't look like it is, unfortunately. So to deal with this issue, what I'm going to do is take our control feature, delete the sphere from the scene, go into our procedural terrain, edit the object, and we're going to remove that connection that we have for our range control. Let that reset. And now we're back to where we were. I'm going to go ahead and save our scene out. And then I'm going to close view and open it back up and reload in our scene. Okay, so I've gone ahead and just reloaded everything. What I'm going to try this time is just creating a sphere. And we're going to move this into our controller layer. I'm just going to rename this feature and not put the control in front of it this time. I'm going to set our position to 80 meters on the Z and 20 meters on the Y. And now before I connect anything, I'm going to try to create our animation ahead of time. I'm going to enter in our meter unit just after the position to make sure all of that is set correctly. Go to the end of our timeline. And we're going to manipulate this on the x-axis, 20 meters. And now our animation is working correctly, and we can see that movement for the feature. So let's go to our material. I'm still going to give this a new name, null2. Turn off all our render options and the G buffer. So now let's take a look at our position, and our movement is going between 0 and 20 on the X. So we're going to use that to control that largest feature. So it looks like maybe because we had connected the node first before making modifications, that might have caused the issue. Also, the reboot of view might have caused or might have fixed that issue. So we'll load back in our controller node. getting rid of the offset variation. And now I'm going to extract the largest feature. But before I connect this, I want to just set up our controller first. Since we're going to be controlling with the X, I'm not going to modify our offset at all, in case that was causing the problem. It doesn't look like it was, but just to be sure, kept with the X, which was not modified. So we're going to change to feature position, and we need to set our low range to 10 and our high to 15, just like we decided, and the X range to 20. So now we can connect from our constant node to the controller on the X. And it doesn't look like the terrain was manipulated, and that's a good sign, because we're still at frame 0. And it looks like that worked correctly. So now we have the terrain and our Voronoi profile getting larger as it starts to morph from those values that we set of 10 to 15. So I'm going to save the scene now that it's working. So sometimes it just takes a little bit of a change in how you apply some of the different features to your scene. And sometimes it just takes a reboot, closing out the program, opening it back up, because it is sort of a process. And sometimes a process that can get a little unpredictable, because sometimes even the simplest of things won't work. So now this is set up, I'm going to create another preview, and we can take a look. And now we can see our terrain growing as it's changing with the Voronoi profile and the largest feature of it getting larger. So it looks pretty cool. And it's more of a boiling effect. If you want, you might want to reverse the function if you wanted to create more of an erosion. Because right now it looks more like lava bubbling out of the ground without the correct materials. And actually, if we did want to do that, a really easy way is just to switch the high and low number. And that way we don't even have to manipulate the object animation. So we'll set our low range to 15 and our high range to 10. And that's just going to reverse the blend that we had set up in the original function to distribute the 0 to 1. So now 0 is 15 rather than 10, and 1 is 10 rather than 15. So we're starting out with a larger feature to begin with, and then shrinking it down. Let's render out the preview and take a look. So now we can see more of that shrinking effect. And it looks a little more like erosion, even though we have such a huge change in the origin of that other material and the object blend itself. But overall, it looks pretty cool. Where it looks like a rock is sinking into the grass area. So there's a lot you can do with this. And I think what I want to do is select our control ratio, go to the last frame, and right now we have a pretty large change in its position. So what I want to do is just modify that so it's not so great. So we're not manipulating the origin nearly as much. And I'm just going to render out one more preview, and we can see how that looks. And now we can see a much slower origin change, but still our largest feature changing in the same amount as it was before. And we have it shrinking. If you needed to, you could connect another object to adjust the origin of the individual materials so that you could have these features moving, or you could change something like the metascale, really anything you want. Anything that is extractable can be modified with what we just created. So this node that we just made is really powerful, and you won't have a problem creating animations or controls unless you run into the keyframe problem that I just had. But other than that, it's pretty straightforward, and from most of the tests we've done with it, there haven't been any issues. And we're just going to go on and expand upon this just a little bit more. Go ahead and just save our scene. What I want to do is just take our grass and change its color a little. So we'll select our procedural terrain, edit the material, edit the function, and now we have our color. And what I want to do is create a blender and blend between two different colors. So what I'm going to do is basically just load in one of my own nodes that I've created that is not included with this training. You can make a modification however you want. I'm going to use the node I generated, created for this purpose. It's available with the MetaTools collection, or the Meta Node collection, version 1. And I'm just going to connect to my HLS shift intensity range. Basically, it's a less intense version of the HLS shift. So instead of the hue ranges being very drastic, they're a lot more subtle, and it's basically just sort of a sensitivity control. So now we can adjust luminosity, saturation, and the hue a lot easier than just the native control. But what you can do is just use the regular color node, color correction, HLS shift, which basically has the same controls except it doesn't have an intensity slider. And what I've done with this is actually have the node in some of the settings adjust the oversampling that can be caused by the luminosity saturation changes. So there is a little more internal work with it, but for the most part it's a less sensitive version of the HLS shift. But you can use the same thing to create what it is we're doing right now. Increase our intensity, which adjusts the sensitivity of all these sliders. And now we just have a blend going from green to more yellow. And our blender node, and we're just going to connect this to our range controller using the exact same settings that we have for the feature and how we change the largest feature. So we'll set our X range to 20, and our low and high is 0 and 1 since we're working with a blender. And our controller is going to be feature position. And we don't need to set up an offset because the X was null and there were no changes to it. And click OK. And close all this out. Now I'm going to create a new save, variation number 5, or sequence 5, and create a new preview. So now we can take a look and watch the animation, scrub through, and now we can see our grass turning from the green color to a more yellow color. We could also modify the rock color that way, or anything. Adjusting a bump, going back into the terrain function and modifying one of the procedurals. We could also modify the position origin. There's really a lot we can do with this sort of setup. And now that you know how to create the node, and you have the provided node and also the one you completed, if you were following along, you can use that to create some really amazing animation within Vue. Now with the new graph options and this external dependency, along with connectable constants, creating these types of tools is extremely easy, and the amount of control you have over fractals and the like is just limitless. And please don't feel constrained to what I've shown you. One thing you could do that'd be kind of interesting is, instead of using these null objects in the scene, you could connect the node we created to the camera. So as the camera moved closer to an object, you could have the material change or modify a terrain in any sort of way. So there's a lot you can do with it, and just kind of let yourself go with what it is you're using to control these objects, because the interactions you can create and just these dynamic links is going to create some very, very cool stuff within Vue.